ControlLogix configuration for 4 to 20 milliamps gas detectors. Gas detectors are going to use user-defined types or UDTs, which are the gas detector and the gas detector diagnostics and alarm set points. The gas detector is going to have a value, a warning, an alarm, an in-call, enable, fault, link OK, common trouble alarm, also a flag for simulation, for alarm simulation, then the raw value and the range. The one for diagnostics and alarm set points is going to have the alarm high or warning, the alarm high, under range, over range, then the low calibration and high calibration thresholds. Let's take a look at the part of the program that handles gas detectors. This is the block that casts the gas detectors. For example, here we are handling or casting gas detector number 2. So we are calling with parameters the data acquisition gas detector block with a number 2, that's the index for that particular gas detector. Then the next input parameter is going to be the analog channel with analog raw data that comes from the analog input channel for that particular 4 to 20 milliamp gas detector. Then the next input parameter is going to be a gas detector itself, in this case analyzer transmitter number 2, and then the return parameter is going to be a refreshed image of gas detector number 2 as processed by this block. Then we have an extra flag here, which is the communications flag or status for that point, in this case a point IO, that is going to be handling the remote IO point for this particular gas detector. Let's take a look at AT number 2. We go to our program tags, and then here is an array which is called AT, and AT in this case has 50 elements of the gas detector type that we defined previously. So gas detector number 2, we expanded, and we have all these parameters that were defined by the user-defined type named gas detector. So we have our value, our alarms, status flags, our common trouble alarm, simulation flag, this is going to be the raw value, and the range for this particular detector. So again, this particular gas detector data type was defined here. Now let's take a look at the inner guts of the gas detector block. So these are the input parameters we discussed. So we have the index, we have the raw value, and we have the gas detector variable right here. These three guys. Then after that block is executed, then we expect the refreshed image of gas detector number 2. So first thing we do is we call another function block, which is the scaling block, which requires 2 input parameters, the raw value from the 4 to 20 milliamp analog input channel, and then that particular range for gas detector number 2, and then we get a return parameter which is the value in ppm. So this is concentration value coming from this scale function block, which is fairly simple. It's just math, takes the raw value, the range, and it converts it into ppm. Right here, this is the AT value in ppm. Then we take this gas raw value and then write it into the actual gas detector.raw value. Next order of business is the alarm definition. So when we have a detector enabled and the link, the communications link for the remote I/O point is okay, and the detector is not in fault, then if the gas detector ppm value is greater than our gas detector set point, alarm high, then after 10 seconds, see how we are using this timer, and the index for this timer array is our gas detector index. In this case would be number 2, but could be 3, 4, 5, anything, depending who is calling this function block. Then the preset value in this case is 10 seconds. So then after those 10 seconds, we're going to have this flag, gas detector dot analyzer alarm high. Same thing for the alarm number 2, or high gas alarm. We have the detector enable, link, not fault. Then above our analyzer high alarm threshold, in this case is 10 ppm. Then after 10 seconds, then we're going to have the gas detector analyzer alarm high enabled. Notice here we have a bypass, so we can simulate this alarm for debug or troubleshooting purposes. Then we have our detector fault. So if the detector is enabled, is not in calibration, if it has an under or over range, or the link is not okay, then after 10 seconds we're going to have our gas detector fault. All these values are defined in a program tag or program variable right here. So this is the gas detector set point, and we have all these values predefined. For example, this is our warning, 5 ppm in this case. This is our gas alarm, 10 ppm. And these are the raw values for our under range, over range. And this is the window, the values for the definition of an in-call status. This variable is not an array, it's just an UDT, so it is in this case used for all of the gas detectors in this program. So the in-call definition, so if we have a link okay, so we're communicating, then if the value is in between these two thresholds, then we're going to have our gas detector in-call definition. Common trouble alarm is defined by either a gas detector fault, an in-call, or link not okay. Then we simply return the updated version of our gas detector. This function block is called for every single gas detector in our project in the same fashion. So for example, this gas detector number 10 is located with station 43. So this is the analog input, channel 0 at station 43, calling this gas detector function block. And finally, if any of our gas detectors is not enabled, the HMI is going to give us a warning showing that we at least have one gas detector disabled.